morning, good afternoon, Algebra 2 students. Today we are going to be talking about geometric sequences. What we did in the past is we have been working with arithmetic sequences, and in an arithmetic sequence, to go from one number to the next, we need to add a common difference. Now what we are going to do is we're going to multiply by a common ratio to go from one number to the other. So this first one is a little bit easier, and these next ones get progressively more difficult. So if we start with 1/3, we want to say, okay, can we figure out this next term? 1/3 to get to 1. What do I need to multiply by? Or what do I need to take 1/3 and multiply by to get to 1? Well, if you don't know that, let's go to the next one. To go from 1 to 3, what do I need to multiply by? 1 times 3 gives me 3. Now to get from 3 to 9, is it still 3? It is. 3 times 3 gives me 9. And actually 1/3 times 3 gives me 1. So my common ratio here, when I go from one, right, to the other, I am multiplying by 3. So 9 times 3, what does that give me? Well, that gives me 27, okay? All right, let's look at this next one. 1024 to 256 to 64. Okay, now how am I going from 1024 to 256 to 64? That I could struggle with, okay? So let's go back up to this first one, and actually to figure out that common ratio, what you can do is you can just take one of the terms in your sequence and divide it by the previous term, and that gives you your common ratio. Okay, so you can see 9 divided by 3, that gives me 3, and that's telling me what I'm multiplying by each time to get that next answer. So if I don't know, I'm going to take one of my terms, 64, and I'm going to divide it by the previous term, 256, and I get 0.25. That's that common ratio. So what's happening here is 1024 times 0.25 gives me 256, okay? And 256 times 0.25 gives me 64. And if you need to use your calculator, that's okay. So 64 times 0.25 gives me 16. Okay, so that's my next one. Just for time's sake, I'm going to skip this next one, okay? But what should we have learned here? We're dealing with geometric sequences. We're talking about the common ratio. There's a number that's being multiplied to each term to get the next term. If I can't figure out what that was, like this one, I talked about finding that common ratio, which is that number that we're multiplying, by taking one of the terms in the sequence and dividing it by the previous term. Okay, let's cruise to our next example. What exactly is a geometric sequence? It is a list of terms whose ratios of successive terms is a constant called the common ratio. And this is what I just talked about. Okay, so we have one number, right? We go to the next number and the next number and the next number. What are we multiplying by, right? What are we multiplying by to get that next number? That's that common ratio. So I take one of the numbers in the sequence. That's what that a sub n means, okay? A term in the sequence. And then a sub n minus 1 is the previous term in the sequence. Okay, now can we identify if something is geometric, is a sequence geometric? So if so, find the common ratio. So what we need to check is when we find that common ratio, we need to make sure that it works for every single term that we see, okay? So to go from 1 to -1/2, what do I need to do? I multiply by a -1/2. So that means my r, right, is equal to -0.5. Okay, and you can go ahead and use your calculator if you need to. So if I take 1 times a negative 0.5, I get a negative 1/2. Now let's confirm that it keeps working. Negative 1/2 times negative 0.5, and you can use your calculator if you need to. Well, that gives me a positive 1/4. Positive 1/4 times a negative 0.5, that gives me a negative 1/8. So yes, this is a geometric sequence because that common ratio, taking one of the terms, dividing it by the previous one to get negative 0.5, well, that works each time as I'm multiplying. Okay, so let's try it again. 21 to 4.2 to 0.84. So it doesn't matter which term you pick to find that common ratio. So let's take 0.84 here. So I'm going to go in my calculator and I'm going to say 0.84 divided by the previous one, 4.2. And that gives me a ratio of 0.2. Okay, so I'm going to write that down. Now, what we can do is another way to check this, right? So we know from 4 to, if we took 4.2 times 0.2, we would get 0.84. We could also take 4.2 here and divide it by 21, and that should also be 0.2. Or, you know, if this is going to be geometric, 0.2 needs to work each time. So you would just take 21, right, times 0.2. That gives me 4.2, and then times 0.2. That gives me 0.84. Again, we have a geometric sequence here. Okay, here's the formula you're going to need today for geometric sequences to find the next terms, or the 7th term, the 10th term, whatever term they're asking for. So that a sub n, what does that a sub n mean? That a sub n is equal to the term that you're finding, the last term. Okay. What is n? N is equal to the number of terms in the sequence. A sub 1 is equal to your first term. And R is equal to that common ratio. All right, let's cruise. I've put my work there, spoiler alert. Find the 17th term of the sequence. So we start with 1/4, 1/2, 1, and 2. The very first thing that we want to do is we want to find the common ratio. Okay, so that common ratio doesn't matter which numbers you pick. I personally would pick the easiest ones you see, and those are not a fraction. So I take this term right here, 2, and divide it by the previous term. 2 divided by 1 is equal to 2. Okay, now we're going to take our formula. A sub n is equal to a sub 1 times r to the n minus 1, right? We are trying to find that 17th term. So that right there is my n. 17 is going to go in for n. A sub 1, that's my first term, 1/4. That's going to go in for the blue right here. And then the green, that's my r. That's 2. So what I did is I plugged in my values right here in this next line. Now all I need to do is simplify and make sure you use order of operations. Some people will want to multiply 1/4 times 2 first, but you can't do that. You actually have to do 2 to the 16th power first. When you do 2 to the 16th power, you get 65,536. Then you multiply by 1/4, so order of operations, and that gives us 16,384. That's the 17th term in that sequence. Along the way, if I'm going too fast, make sure that you pause this, write down any questions that you might have. Okay, let's do another one. Geometric means terms between any two non-consecutive terms of a geometric sequence. Write a sequence that has two geometric means between 3 and 81. So the first thing that I like to do when I'm figuring this out is I like to write it out. So I have 3, comma, then 2 geometric means in between. That means I have a space for another number and a space for another number. That's those geometric means right there. And then I have 81. Okay. Well, what do I know? I know my first term, I know my last term, and I know the number of terms I have in this sequence. 1, 2, 3, and 4. So I'm going to fill that in right now. So a sub n, that's my last term. That's 81. A sub 1, that's 3, my first term. I don't know my common ratio, but I do know the number of terms I have. That's n. 1, 2, 3, 4. So that's 4 terms right there. So I'm going to plug in 3 for a sub 1, 4 for n, and 81 for a sub n. And I have that right there. Okay. Next, what I need to do is I need to solve for r to get that common ratio so I can fill out the next two numbers. Okay, so let's go. I need to first simplify that exponent. So that's going to give, well, I did two things. Okay, let's look at what I have. I have 27 is equal to r to the third power. Before you panic and say, how did she get that? I simplified the 4 minus 1 to give me 3. I also got rid of the 3. And to get rid of the 3, I need to divide by 3 to both sides. So 3 divided by 3 cancels out. 81 divided by 3 gives me 27. Now I have 27 is equal to r to the third power. I need to figure out what r to the third power is. I'm going to use my pen and I'm at home on my computer. So it doesn't look as nice as it would in the classroom. I need to take the cubed root to get r by itself. And the cubed root to get r by itself. Now, we did this in a previous lesson. Some of you know that what the answer is, that the cubed root of 27 is 3. If you don't know that the cubed root of 27 is 3, this is where we prime factored. So we said, okay, 9 times 3 gives me 27. 3 is prime, but 9 isn't, so I'm going to keep factoring it. 9 is equal to 3 times 3. And now since I have the cubed root of 27, I have 3 times 3 times 3. I'm looking for groups of 3 because of this cubed root. I have one group of 3, and that number, and there is actually 3. So that's gone. The answer is 3. So that's another way. Again, cubed root, what times what times what gives me that number 27, 3 times 3 times 3, okay? So there's a few ways that you can figure that answer out. Okay. Again, if I'm going too fast, make sure you rewind. It's hard, when you don't have a class in front of you and you're just talking to a computer. So take that time to rewatch things, pause things, slow it down if needed. Find the missing information. If r is equal to 1/3 and a sub 4 is equal to 2, what is the first term in the sequence? So anytime they give you a problem like this and you see a sub 4 is equal to 2, at that point you know that, hey, that's my n, meaning I have 4 terms, okay? Let's talk about what we have here. Well, I know my common ratio, my green, that's 1/3 power. So, I'm sorry, not power, just r is equal to 1/3. So I would put 1/3 in this green spot right here. I also know my n, and my n is equal to 4, okay? And I'm telling you that when you see a problem like that, like a sub 4 or a sub 10 or whatever they give you, that number is your n right there. So I know I have 4 terms, so I put 4 in for the purple right there. I do not know the first term. That's what I'm looking for, that blue. But I do know the last term, a sub 4 is equal to 2, okay? So let's fill in now what we have. We have 2 is equal to a sub 1 times 1/3 to the 4 minus 1 power. Excuse me. Now we simplify the exponent there. So 2 is equal to a sub 1 times 1/3 to the third power. Next, what I'm going to do is I'm going to simplify 1/3 to the third power. So in your calculator, if you don't know how to do those third powers, let me show you here. You have 1 divided by 3. That can be your fraction for you. And then most of you, if you have a scientific calculator, you have a little hat right there. Okay. And then you put 3 and hit enter. And that would give you a decimal, unfortunately, if you're struggling. Otherwise, I would suggest doing 3 times 3 times 3, which is my denominator, which is 27, and 1 times 1 times 1, which is my numerator, so 1 over 27. Okay, right? 1 times 1 times 1 is 1. 3 times 3 times 3 is 27 to give us 1 over 27. Okay, now and finally, I need to figure out what a sub 1 is. And a sub 1 is 54. So if you're like, wait, how did she get that? Let me show you over here. 2 is equal to 1 over 27 times a sub 1. To get, that's a bad 2. To get a sub 1 by itself, I need to multiply by the reciprocal. So that's 27 over 1. So I'm just going to put 27. So 2 times 27 is 54, my final answer. And that's it for today, guys. Let your teachers know if you have any questions. Rewatch if you need to, slow things down, pause after each step, so on and so forth. Have a great day, guys. We miss you all.